Chapter 1.8, Words to Symbols. Oops. Words to symbols. Our target today is I can translate word phrases into algebra expressions. Okay. One formula that we often use in these types of problems is what's called the distance formula. And the distance formula, it's called the distance formula for uniform motion, is equal to the rate times the time. Abbreviated, it's D equals R times T. All right. So first we want to start out by just translating simple expressions. So we want to take the words in English and translate them into algebra. So example 1. So 4 less than twice a number. Now the key here is the less than. Okay? When you see the less than, you always do what comes after it first, and then what's in front of it second. So twice a number. So first thing you do is select a variable. So we'll just use n. Okay? So twice n, 2n, and then we want 4 less than that. So minus 4. So this in algebra says 4 less than twice a number. Okay? Example 2. Whoops. The sum of twice a number and its square. Okay, so sum tells us that we're going to be adding. Oops. Twice a number tells us that we're going to be multiplying. And then we have its square, which tells us that we're going to be doing some power. All right? So the sum of twice a number, so again we'll let n be the number. So twice the number would be 2n, and the sum would be plus its square, so n squared. So 2n plus n squared would be the translation from a phrase into algebra. Example 3. The difference between a number and 3. Okay? So difference tells us that we're going to be subtracting. Okay? A number tells us that we're going to use a variable, so that's going to be our n. And 3. So we're going to use the number 3. Okay? So the difference between a number and 3. So that is n minus 3. So that is the translation of that phrase. Example 4. Whoops. Okay. Example 4. 4 less than the product of a number and 3. Okay, so we have those keywords less than. So that means that we're going to do this part last, and this part is going to come first. So the product means multiply. So the product of a number is our variable. So the product of a number and 3, so we'll use x this time just to use something different. So that's going to be 3x. So the green is represented by 3x. And then we want 4 less than that, so it'd be minus 4. Number 5. The quotient when 8 is divided by twice a number. Okay, so we have a number, so that's going to be our variable, and we have twice that number. What does quotient mean? Well, quotient means we're going to be dividing. The quotient when 8 is divided by twice a number. So that's 8 divided by 2x. Okay? All right, let's move on to a more involved example. Let's look at number 6 here. A rectangle has width of W yards and perimeter of 48 yards. Find the length in terms of W. Okay, so whenever there's a geometric figure in the problem, the first thing you want to do is draw that geometric figure. So we're going to draw a rectangle. Okay, and then label what you know. This is the width, so this is also the width. Okay, then what does perimeter mean? Okay, perimeter means the distance all the way around, adding up all these distances. And let's go ahead and name these the length. Okay, so what is the formula for perimeter? Well, I know all the way around is 48, but I'm adding up all the sides, so I have 2 W's to add up plus 2 L's to add up, and that's going to equal 48. Okay, now we want to find the length in terms of W. So in other words, we want to get L all by itself on one side and W on the other side. Okay, so what we want to do then is subtract 2W from both sides. So we have 2L equals 48 minus 2W. Then again, we want to get L all by itself, so we want to divide by 2. And using division property, we can rewrite that like this. And that can be reduced then to 24 minus W. So the length can be represented by 24 minus W. So this is 24 minus W. Okay. Now let's go ahead and look at an example with the distance formula that we talked about earlier. So this is example 7. Anna and Sue rode together. Rode toward. I was spelled road. Rode toward each other. On their bicycles. Sue's rate was 3 times Anna's rate of R miles per hour. They met after 2 hours. How far apart were they before traveling? Express in terms of R. All right, so we have Anna and we have Sue. We have the rate. Well, we know Anna is R and we know Sue is 3R. We have the time. They both traveled 2 hours. And we have the distance. Well, we said rate times time equals distance, so distance is 2R and 6R. And so they were 8R miles apart. Okay, so in other words, they're traveling towards each other, and Sue traveled 6R and Anna traveled 2R. Okay, so they met about right here, but the total distance that they were apart was 8R.